Hello, okay, so we're going to do two things today. One, we're going to go over UML as just a rough idea. Two, we're going to do a simple example. I'm going to basically do the lab in terms of all the exercises. Not all the exercises, sorry, right? Just the UML. And then once that's all done, we'll probably look at an entity system very shortly. So it's going to be about 15-20 minutes, hopefully. I will not go over that. So let's go through what we need to do. So to begin with, we need to talk about, well, what's the difference between UML objects and, for example, EDP, right? Or ERD, actually, whatever Yashesh was showing off. So the big difference between them, right, is the typical UML format, or the actual specification of the format, specifies a very kind of not necessarily strict, but is very confined in terms of the usage of the relationships between things, right? So, for example, a very common thing is that the ERD, which is the entity relationship diagram, which is the thing with the crow's feet, which looks like a circle of things coming out of it, and like all the 1 to m things. That's very, very, very useful for databases. So, well, this is a new computer that I'm just setting up now, so I don't have SQL on this. But if I had SQL on this, I could like pop open an SQL database and like a design view, and I could probably get some diagrams out there that look pretty similar to what an ERD looks like. Because that's really the main case, right? When you actually care about one-to-many relationships much more. And something like this, they're mainly just to demonstrate ownership. And that's kind of the big importance of UML, is the ownership thing, right? And ownership is very important when we're doing OOP, or when we're really doing any programming, right? It's nice to know which bit of code owns which. Otherwise, what we'll do is we'll get into situations where we don't know the owner, and since we don't know the owner, we can't make expectations on how a system is going to behave, because it gets very complicated, right? We can't trace it, we can't isolate, we can't encapsulate it, because we don't know the ownership, we don't know I don't know, the general idea, right? You get that general idea, hopefully. So we're just going to start by doing some stuff. So there's a few things here that we care about. The first thing is was obviously interfaces, there's classes, and there's this class. So there's these two types of classes. Effectively, this is the one we prefer. This one's also okay. You may go, these things are the same thing. They're not. The big difference between them is that with these ones, you'd even put the methods here, right? You don't have the bar, right? So the bar kind of separates the foods and the methods. I prefer it this way. This way is also okay though, if you prefer it like this. So here's my class, right? Let's begin by doing a very simple class. So we'll just do session, right? Session has a few things. It has like a day of week, for example. It has, and we're just gonna make this a bit bigger, just because it should be, which will only work if I make this bigger, or if I do this, probably. They've changed the app a lot since I've last used it. Control C, Control V. There we go. Okay. That's kind of awkward. Is there a way for me to just duplicate it? Yeah, but it duplicates at the bottom. That's fun. Okay, so we'll just do this. And then we'll just edit these. Okay. So the first thing you notice is these negatives, or these minus signs at the front. Or hyphens, whatever you want to call them. This probably could be a local. This could be local time. And then we have end time, which is also local time. These hyphens basically signify that these are private methods, and private methods are really nice and important. Because when we do private methods, they're basically dictating that, obviously they're just for this class, right? And so that's the whole point of UML, is to kind of be able to get at a glance, understand exactly what exposure this class has. So a good method here would probably be get, we'll just add both of them here. It doesn't really matter that much. Command plus D. No, oh, that does work. Okay. Am I supposed to command plus F for sign? I won't do all of it for you, but I will do obviously quite a decent chunk. Because I presume most of you have already done this basically, so I'm just kind of going over the same idea that you've probably also done, right? So I just want you to get it right in terms of, not so much the lab, but in terms of the actual assignment. So to me, you getting a few extra marks in the lab is not that relevant. Okay, so we have our session here. And then we're going to create 3 subclasses of this session. And there's a few ways you can do this. You can see there's so many different things here, right? These are instances. That's what an object type is. There's all this other stuff here, like this is actually a table with foreign keys. There's components with attributes, which we'll probably never see, but maybe sometimes later. There's annotations for things like overrides and stuff, which you won't really need to use. There's one thing I'm looking for. Sometimes they add them. Nah, okay, I'll just use a normal class here. Okay. Sometimes it's like an easy option that will automatically draw the line for you, which makes life easy. And then I'm just going to draw this line from here. And the key thing is I want it to all point into the same object or into the same thing. And I want to change this line, and I want to change it for this to the inheritance arrow, which is a empty arrow like this. And I also want to increase the arrow quite a bit because it's very, very tiny. Wonderful. Okay, 25. Beautiful. Okay. There's my arrow. Let's duplicate this class and move this class into the middle. Duplicate this class and move this class into the middle. So the first thing I always begin with when we're doing these UML diagrams is we always want to try to make it so that we work in each component of them separately. One, it forces us to view the system independently, forces us to have good encapsulation. Two, I'm not going to fill these in. I don't really want to waste too much time going through over that. I presume you guys can fill that stuff in. I will do the arrows there. Two, so the first thing is we want good encapsulation, right? That's really important. The second thing is, lining these arrows up is always fun. It helps us see the system without all the extra complexity that typically can happen. And so it allows us to basically simplify the code that we're doing, simplify the system that we're doing. And 1, 2, this, like this. Honestly, I always make the lines a bit thicker. Yeah, I make them like 2. It makes lining them up much easier. And sometimes the other thing that you can do, you can line up to the entire object rather than lining up to the entire thing. And sometimes that makes them line up much nicer. That's a bit better. So if we then actually remove this and point this into here, well, I'm just going to delete this and just be cheeky and just do. See how annoying that is when it doesn't exactly line up? I probably do not need to fuss with this as much as I do. But it will annoy me if it isn't perfect. That still isn't perfect, but it's good enough. Anyway, and so I like having them lined up like this. I always do it. You guys don't have to. You guys can just kind of live with it however you want to do it, right? But I always spend extra time. I know there's other ways you can line them up, but I'm apparently too lazy to do those right now. So we're just gonna... Sometimes that works, but apparently it does not. It used to work. Anyway, instead, I guess I just do this. That's good enough, right? And so you just want them to all point into the same one. I prefer it like that. It makes it simpler. You can make them point 3 different arrows if it's easier for you. I don't care. But we really want to work in things isolated. So what I like to do is, this is this component done, and I move it to the side. I don't care about it anymore, and I'm going to work on a different component, right? And then we can combine them all together at the end. It also helps our diagram become simple, and we don't have to spend so much time putting everything together and spend so much time trying to like connect everything and trying to make everything look pretty. So next thing we want an enrollment system. Right. I'm not going to fill out most of this enrollment because this is actually part of the thing that I do want you to do, but I will add the fields that we require. So we require an offering. We require, let's not do methods for this one, just for simplicity. And this should be a negative. Right. So the first thing here is that we should know about is that we want to kind of copy and paste our fields a bunch of times, just make life easy. So we want a course offering, we want a grade, which I'm going to do as an optional. You can do however you want. And a student. The reason I'm doing it as an optional is because I don't view a grade in my system as required, because you may have not gotten a grade yet, because you may have not completed the course. Or you may have not gotten the grade because you dropped out, or various other reasons. Okay, So there's my array, there's all my stuff, it all looks good. And then from this, I can create my other stuff. So I'm just going to copy and paste this just to make life easy. Create a student class, which just holds a series of enrollments. Right, and that's it. Right, it's going to hold other stuff too, obviously. It's going to have an enroll function or whatever. But in the case of our data, we're just going to do this. I've decided to do less because I feel like I don't want to waste too much time. Okay. Now, let's talk about diamonds. Okay, so there's two kinds of diamonds that we care about in UML, right? So the first thing you've seen here is the arrows. These arrows here are what we call straight up inheritance, right? So straight up inheritance, I mean, I don't think anyone calls it straight up inheritance. It's just inheritance. And it just indicates that obviously that this is a child class of this. This indicates aggregation, and then there's also one for composition. And then there's also one, obviously, for association. Now, the difference between them is if it's empty like this, it basically means that if student, or rather if enrollment disappears, the student won't disappear, right? And so this is kind of important here, right? Is what way do you hold this relationship? Now, either of these ways is valid. Looking at this now, I personally would probably flip this and would personally place the student as the controller of the enrollments, right? Just as a personal preference. And then would state, okay, there's one student to every many enrollments, which I use the asterisk for, and I'll make the asterisk a little bit larger just for visual effects. Right? And for some reason, I think I placed it in the object, which is not what I intended to do. Is there any way for me to just skip by it? Yes, it is. Okay, wonderful. Okay. So this indicates that student owns enrollment. That's all it indicates. It indicates ownership. Just what I was talking about before, that's all it does is ownership, right? Now there's one other arrow we care about, and that one other arrow is sorry, I'm losing my train of thought. The one other arrow is when you actually state that the ownership is kind of cascading. That's the typical operation that we use in tables, is we cascade them. So it means that if the parent gets removed, that operation of removal cascades to all the children, right? In UML, it's just called, I forgot the name of it. I just said it previously. No association, no aggregation, composition. I'm pretty sure it's composition. Let me just check that. I don't want to be wrong. Yeah, it is composition. The one thing you should know about composition is I don't think it's actually a standard UML relationship, but we still use it everywhere, so it's still fine, right? So this is, I believe, the standard one, but you'll still see aggregation composition everywhere, and it's basically a binary association, which means that as soon as one of the parent ends, the other one ends, right? So it has to be full. Okay, let's go and grab our grade. So this is a grade, right? And there's a few things about this grade that we care about, and so it's actually talk about those things. And so the first thing that we care about is for example, like passing and so on, right? So what I'm going to do is I'm going to be a bit cheeky here and have a grade, which is whatever. I don't like calling it type here, but I can't think of another name in a short enough period of time, so I'm just going to call it grade type and a mark int. That's stupid. We won't do that. We'll do this instead. So we'll make a function, and also we'll add a spacer just to make it easy. And we'll do this function, and we'll do get grade, which has yeah, that's fine. I still don't like it, but I'm still gonna do it. So this is not something that you would be expected to do for your lab, but I'm still gonna show it off because it shows off enums, which is what I care about. Now enums aren't actually an option here, but they are still definitely a valid option. Maybe they are somewhere. I just can't see them. So instead, what I do is I don't use that. I just grab a normal interface, right? And I rename interface to enum. So it's still a valid option. It's just, it's not on the thing there, not on the drop down. I'm going to call this grade type. Now, if you don't know what an enum is, that's okay. An enum is basically just like a series of hash defines in C, or a series of constants in Java / Python. It basically just represents a series of constant values that you want to assign to your program. And so I typically do them all uppercase. It's up to you whether or not you don't want to do. So passed, failed. You know what? Let's do the. So we got like satisfactory. I think it's SF, SY. Then there's also fail, and then there's also pass, credit, HD, and distinction. There's many others, but you just basically list them all here, right? And you can also give these integer values if you want, right? But the whole point here is it allows you to assign some kind of constants to your things, right? Now, what's interesting here is that this isn't actually a relationship, right? And this is one of the reasons I'm doing this is twofold. So one is that it's not a direct relationship. It's actually just like a kind of like a, I guess it's almost kind of like an association, right? If that makes sense. So we're saying we're associating this grade type to this return result, but this grade doesn't own this grade type. It doesn't own it, right? And so it's almost, the other idea is it could also be almost like a dependency, right? So you're depending this grade type upon this other thing, right? Okay, so what does that mean? Well, that basically means that we're going to return this grade type here from grade when we ask for grade. And that's going to come from this. And so for that to work, right, we're obviously going to need, just checking my microphone's still working, yay. We're obviously going to need some kind of relationship to bind them together, right? And so the simplest way is to basically just say, hey, these two, this is almost like an instance of this grade, if that makes sense. So I prefer just to chuck it and say, hey, there's a few things you can do. I wouldn't do a dependency relationship. I'll just do a directed association and say that this is associated to this, right? That is okay. There are other ways you can do it too. And so if you want to do it another way, go for it, right? But a directed association is probably what makes sense here, because you want to say, hey, for example, this grade creates this grade type. That's effectively all you're doing. So we're going to flip this arrow. We're then going to go and grab this, and we're going to convert it to an association. Now, this is the one I use for association. Oh, look, there are the other arrows here. Great. No, that's not the one I use for association. This is the one I use for association. And I also use a dotted line. Now, dotted line is actually quite important. So we need to make sure this is dotted, right? And this indicates association, right? And we often also put a bit of text above it to indicate what kind of association. So we're going to say maps to, right? So this maps to a grade type. And we're going to make this text a bit smaller because it is a bit large. Right? So we're saying every grade maps to a grade type, right? Where it's like a one-to-one relationship. And we're actually going to flip this because this arrow is the wrong way. It should be pointing into this. You want to say this is associated to this, right? Every grade type maps to a grade. The arrow kind of matters, and almost like with these, where you want to point this towards the owner, you want to point this towards where the variable is coming from, or going to, I guess. Wherever you see this variable here. Now this grade is just going to be related to this in a pretty straight way, so we can just go here, and we can just go, okay, let's grab this, let's do an arrow, and we're just going to do, no, let's grab this. Are you going to allow me to do an arrow out of you? You're not? Okay, we're just going to do this and pretend that's okay. Wonderful, it worked. Okay, now we're just going to grab this, make the arrow look a bit nicer. Bring this back a bit more. Bring this down. There we go, that looks a bit better. I mean, it could be made probably a lot better, but that's okay. And obviously we want to point the arrow in a different way here. But the big problem here is that we really want the association to go this way, and we don't want it to be an association. Instead, in this very specific case, we want it to be this. So we're actually going to move this whole thing down, and we're not going to be smart. We're just going to kind of let these things be different, because it'll also be confusing if we put them as the same one. Okay. Wonderful. And we're not going to make this dotted because it doesn't make sense to be dotted. So what we're saying here is that enrollment owns a grade. So once you have given a grade for your specific enrollment for a course, if I delete the enrollment for a course, my grade should also disappear. Now, you may have a different opinion about that. And for example, you may have a different opinion here. You may believe that this relationship should not be optional here, right? You may believe that, or you may believe straight up that the enrollment owns the student, right? Or you may believe that the student owns the enrollment. The only reason I'm keeping it white here is because I think it's actually reasonable to keep it white. You know, if a student leaves the university, delete from their system, you probably should still keep all the enrollments that they had, right? But you may just want to delete the student entry. There's definitely a reasoning there. I don't necessarily know if I agree with it. I'm just going to keep it with it just for the sake of it. It's a one-to-one relationship for the grade. So just do a one-to-one, right? You have one grade for every enrollment. Now this piece is almost done, right? So this could have actually been done, this grade could be done isolated, but I just kind of wanted to show in context. Now one last thing is obviously things like courses and stuff like that. Now I'm not really going to go into that because I think that was pretty well covered, but basically course is just going to map to itself, right? In a many-to-many relationship, because every course can have many prerequisites and every course can be part of many courses as prerequisites, right? So it's a many-to-many. But there's one more thing I want to go through, and that one more thing is what I call specialization for interface types. And this will happen at one point. You want to do a specialization for an interface, right? And doing this has been annoying and isn't always obvious. So we're just kind of going to go through it and make sure it kind of makes sense. Okay. So realization is, let's say I have like an interface, right? And I want to realize that interface in some way. Maybe that's not going to be useful. It's not going to be useful for the assignments. Maybe I won't go through that right now. Maybe I'll go for that a bit later. We'll just connect up these sessions with the enrollments. And we'll say that this is mostly done here. Because time-wise, let's be conscious. So we'll just grab this and we'll merge these two together. And we'll just flip the arrow. Because in my opinion, enrollment should own it. If you have a different opinion, do it. And then just comment why. Make it somewhat clear why. And this relationship here is going to be a one enrollment to many sessions. Which isn't actually even correct. It should be many sessions to many enrollments. Which means that this probably should be... Which means that this probably should be empty. That makes sense. And for those who are a bit confused by that, here's like a probably useful reasoning. So, no, that's me being wrong and me thinking that this was course offering. That makes no sense. Yes, enrollment should have a relationship to sessions, but that relationship should be purely... You know what? This relationship is still fine, and this still should be white, but it's not the relationship I was thinking of. So it's still fine, but it's not the one I was thinking of. The one I was thinking of was course offering, obviously, which would have a course. Let's just do this one. Who cares about the rest of this stuff? I'll just do course and session. So each course offering has a series of sessions. Each enrollment has a series of sessions that you chose for that enrollment. Now, you may not do it this way. You may do this slightly differently, I think. I think there's a bit of flexibility there based on the fact that I use underscores. And I don't think that was already there. Who knows? But we are going to connect these two up. And we're going to say, okay, given these two connected up, now I always like doing it this way. So I always like kind of connect the variables up pretty nicely. And so, for example, you can see this is connected up here. For example, student, I would connect up like this. The only reason I'm not here is because these don't really align nicely if I do that. So I'm just kind of keeping them on the general side. And then we can move this across, and that's okay. We could kind of give this a bit more space. We could probably make this a bit nicer by doing this, and then moving this down, and then grabbing this and moving this across. Right. Anyway, so here's our course offering, and it has a relationship, and it should be the other way around as usual. And this probably should be an ownership relationship, right? So each course offering owns all the sessions, but each enrollment shouldn't probably own the sessions. And so this is actually one thing that people don't often get right. And each session really can only have one course offering. It makes no sense to have multiple. Because you should create new instances of the sessions for each new instance of the course offering, just for simplicity, right? Well, the problem here is that people will make both of these relationships black, right? And I'm sure someone will do it. And that's wrong because you can't have two owning relationships. Because if I delete the enrollment, right, then that means I have to delete the session. But the session is also bound to course offering in a one-to-one relationship, meaning that this requires the session. So if the session goes away, then the course offering, like, how do we delete that? We can't, right? So we can't like bind it back and cascade it back. So you kind of end up with these weird situations where you delete enrollment and therefore you think session's going to go away, but it won't because it's still required by course offering, right? Which is a big pain. And so how do we fix this? And the simplest way is to make one of them weak, like we've done here, right? Where we say the enrollment isn't a strongly bounded connection to session. And the reason why is because it's a strongly bound connection to course offering. So every course offering, every enrollment has a connection to the course offerings, right? Now, to me, I don't like this system either, doing it this way, in personal opinion. I don't think it's flexible enough. The reason why I don't really like this is because and then also one course offering to each. There could be many enrollments just in course offering. And the problem with a system like this is that it's not obvious. So you can't have a relationship like this, right? And so this is kind of one of the ones that aren't necessarily obvious either. Right? So there's quite a few hidden things here. So the big problem with having a relationship like this is in code-wise, what you're basically saying is whenever I delete the enrollment, I want to also delete all the course offerings that are linked to this enrollment, which doesn't make sense because there could be many enrollments asking for the same course offering. So therefore, what happens to those enrollments, right? And so you kind of get this weird relationship. And so if you ever have like a multiplicity relationship like this, you can't have this be owned, right? Because else you would have multiple things trying to delete things and you end up with big cycle problems where everything's trying to delete everything else and it can't because everything requires everything else. So instead, this has to be open. So honestly, I do actually like this being closed. I will make that change. I do think this one can also be closed. I do think these two being closed is fine. I do think these two should be both open though. Because here's the general kind of hint of how you can look at these systems is see how this is kind of like a loop that loops around and around, right? And there'll also be a course, but the course literally won't even have any connections to enrollments, right? So course is just this independent magical entity that's going to be floating over here doing whatever the hell it wants, right? So it's going to be somewhere over here. I'm not going to fill it out, but it'll just be course, right? It'll connect to itself and do all this magical stuff, right? And it'll connect down here in some kind of way. And courses and won't have any ownership. It doesn't really make sense to have course offerings own courses because that's kind of weird. Because again, there could be multiple course offerings to a course, right? And so if you do a relationship where you require the course offerings to own the course, then that doesn't really make sense. So again, this probably should be white. But you still see this cycle here that kind of loops around. And whenever you have a cycle like this, you can't really have two blacks because what will happen is it will bind them together. And basically you end up these problems where nothing will get deleted, right? And they'll just stick around in memory forever. I mean, not really. Java has garbage collectors that go through and verify this kind of stuff. But in terms of data model, it will stick around forever, right? There's no reason for those things to cascade because you have two objects that require each other to exist. It's kind of like this. If you have an object here and an object here, and this object requires this object to exist, right? It says, and they both require each other to exist, and we won't use arrows here. We'll just say this, right? Then obviously, okay, so this object requires this object to exist. Maybe we'll just use like a normal arrow just to indicate this like this, right? And then this object also requires this object to exist, right? Then most people look at this and go, oh, obviously, that's a loop, right? That's never going to end. They're going to require each other to exist. There's no actual ownership here. That's a problem, right? But what people get confused by is when you add a third object. So we're going to go along, we're going to add this third object here. We're going to connect this up to this third object. and then connect this third object up to this object. And we get this endless loop. And we still would loop, right? Everything still requires everything else to exist, right? It's like the recycle sign, right? It's still a loop, right? It's just slightly more complicated. And we still have this loop here, right? But the difference is that in ownership, the course offering only requires sessions to exist, right? Now we could make it so that this would also be fine, right? And hopefully some of you see why this would also be fine. Because this isn't really a cycle anymore, right? This owns this and this owns this. That's okay. The problem occurs when we have things like this, where we kind of have this owns this, and then this owns this, and then this owns this. So it's kind of where everything owns the next part in the chain. But when you kind of have this like outwards thing, that's also okay. And obviously you can have two objects owning the same thing. So there's two problems here about making these black. The first problem is that if these are both black or filled, then what will happen is it will force this thing to be owned twice, which is wrong. And if this thing is black, then what will happen is you have multiple enrollments trying to freeing a single course. The garbage collector saves you from real problems, but if you work in a language like Swift or Squirrel, I don't know, there's a few others, that are what we call, not garbage collectors, but what we call reference counted. You get something called a reference counting problem, where basically you have two objects that require each other to exist because they both are strongly bounded. And because of that strong bounding, it means that neither of them will be deleted because they both require each other to exist. They kind of stay together like that, space couple floating through space, right? Where space is memory. And so they're never going to be freed, and they're just going to kind of float around forever and ever and ever and ever. It just is actually a memory leak. In Java, though, we use something called a garbage collector, which means that we verify these problems slightly differently. And so we don't really care about the objects requiring each other to exist because all we care about is, do they have links to the real world? Are they like linked to real memory that's being really used frequently? Basically, are they linked to the stack? You can still have memory leaks in Java through things like events and stuff, but typically it's much harder to cause. Anyway, so that's basically this. As a quick recap, there's a few things we care about. This is inheritance. This here is an association. So this is associated to this. We could even add more verbs here if we wanted to, and we probably should. So for example, you could say a course runs I don't know. I'll come back to that. Give me a second to think. Each course offering holds multiple sessions. Each enrollment enrolled goes to multiple sessions. That's okay. That's not too bad. Is enrolled in. So we're just adding a bunch of verbs, right? Received a grade. This one's a bit tricky. I don't actually like this relationship here. Honestly, I am completely for removing this relationship. If you honestly feel you don't need this relationship, you can kind of go for it. It's kind of just an awkward relationship. Like, why bound the enrollment to the course offering? I mean, there's a reason why. You're gonna need like some way to get back to the course offering, but it's just such a weird bounding. I honestly would even argue that this isn't even a relationship. And this is just straight up an association. That's actually also completely fine, in my opinion, because it really doesn't require, like, it requires the course offering to exist, which is probably why it's this, right? But it's like, it requires it to exist, but it really just needs a reference to it, and it really should be almost like course offering owns enrollment. That's how it kind of feels like it. Like a course offering has multiple enrollments. I guess you could say each enrollment points to a course offering, says, you could just say like is doing in. So is doing in like T2 or is doing in this session and so on. And then runs per semester or something, or even just like has multiple. Has course offering here and has course offering here is fine. This is a bit of a weird relationship. Maybe there's better names for this. I'm pretty bad at naming things. I think the rest here is pretty nice. And so you can mark every relationship but inheritance, and you should, or maybe, depends on, these two probably don't have to be marked. These ones probably could. But yeah, other than that, be careful with your diamonds. Don't make everything just, try not to make everything just filled, because that does restrict everything. If you make everything empty, it basically is as unrestricted as possible. But you still end up with situations where everything just sticks around in memory. I mean, not really, but like quotation marks, how UML views it. Every object just sticks around because they're not required, right? So you still want them to go away eventually, and that's kind of the point, right? You still want a relationship between them so they eventually go away, right? And so, for example, course is probably going to be bounded to some special entity that holds all the courses, right? And I'd probably also have that special entity hold all the course offerings, because course offering isn't actually held anywhere. There's no place currently that we're holding all the course offerings. Which is why people come along and would probably make this field. It's because they go, oh, I need some way to own this. I would argue that you don't. It's fine here. Yeah, I don't see the point in doing field one here. I know there was questions raised in the forum. I know some tutors say that's fine. I think I would argue it's wrong. Only because I think if you make this field, because you have multiple here, as I said before, just repeating the same thing, just to make it clear. If you have multiple, what's going to happen is you're going to get a relationship that means that you need to have multiple enrollments for every course offering, right? So as soon as one enrollment goes away, you're going to have to free that course offering, but you can't because there's multiple other enrollments that require that course offering. Otherwise, you can only have one student enrolled per course offering, which doesn't make sense. Anyway, so that's everything. This did run a little bit over time, but oh well. Cheers.